welcome to this video. We're gonna solve this equation right here. Okay, so I started here to write everything on the same denominator. Okay, as you can see, the common denominator here for me is 2 plus cosine of theta. I wrote the same thing here. If I write this denominator here, it means that it's going to be multiplied on the top, on the numerator. You know, imagine if you had to cancel it out, we'll just do this and go back to our equation. Okay, to our beginning equation of the beginning. Okay, then I did the same thing here, you know, put it on the same denominator, and on the numerator I have to multiply by this one here. Okay, now that I have the same denominator, what I'm gonna do is just to add I have the same denominator, I'm just gonna add the numerator. Okay, then I add them, and it's gonna give me 13 sine to the power 2 plus 2 cosine, 2 times cosine of theta, plus cosine to the power of 2 of theta. This is equals to 2 to 4 plus cosine 2 cosine of theta. Why? Because this numerator, if you add these 1 on this side, they will be under this numerator, and if I cross multiply, the numerator will be cancelled out, so I will just have this result remaining. Okay, as you can see, all the terms of my equation are cosine, so I need to change this one into cosine. Okay, we know with the trigonometry identity is that sine to the power of 2 sine to the power 2 theta equals to 1 minus cosine to the power 2 theta. So we're going to replace this one. We're going to replace sine to the power of 2 theta by this value here, 1 minus cosine to the power of 2. Okay, so this is it. So as you can see, we can expand this one here, we can expand this term here, while 2 cosine this here, and hold on, I need to take a different color. Okay, while 2 cosine, and here on this side and that other one on this side will cancel out. Okay, and this is going to give us 13 minus 13 cosine to the power 2 theta plus cosine to the power 2 theta equals to 4. Okay, now I will pass 13 to the other side, right? It's going to give you, and this side here it will be equal to minus 9, and here then I'm going to add minus 13 cosine to the power 2 plus cosine to the power 2. This is going to give me minus 12 cosine to the power 2 theta. Okay, and as you can see, the minus we can cancel the minus out, right? So use a different color for that, and divide here because we need to have cosine. Okay, so we can get rid of 12, put in 12 on the other side, so we divide by 12 here and by 12 at this other side. Okay, and this is going to give us, now I can square root both sides of my expression, right? Then I go here and put square root on it, square root, and square root on that one. Okay, so that's gonna give me, therefore we're gonna have theta by using the cosine, the inverse cosine. Therefore theta will be cosine minus 1 of plus minus square root of 3/4. Okay, this means that we have plus minus, means that we have two solutions, two angles. The first angle will be cosine minus 1 of minus square root of 3/4, and the second will be cosine minus 1 of square root of 3/4. Okay, so we have our angle written here. We're going to use the calculator to find. Okay, so let's go ahead. We have here 3/4 square root of 3/4. Sorry, again 3 divided by 4 equals the square root of it give us this one here. We can put a minus in front of it, and then use the inverse, and then find the cosine. It gives us 150. So theta 1 will be equal to 150 degree. Okay, so we can do the same. So theta 2, 3 divided by 4 equals 0.5. 75. Square root it gives us 0.866, and we use the inverse cosine. It gives us 30 degrees, and this angle here will be equal to 30 degrees. Okay, so here we drove a unit circle to show you where the angle are situated on the circle. So the 30 degrees here is pi divided by 6, okay, and 150 is 5 pi divided by 6. So this is this angle here, in red. As you can see, we are in our range of 0 to 180 degree, as like it was asked at the beginning. Okay, so this is actually the solution to our equation which we had to solve from the beginning. Okay, so thank you for watching again, guys, and until next time. In my next video, I'm gonna do a more complex exercise about solving the equation. Okay, so stay tuned, and until next time, bye bye.